So we will get started. Thank you everyone for joining us. My name is Gail Powley. I'm president of Technology Alberta, and we have the honor of presenting a company that's actively using AI in the Edmonton or Alberta areas once a month. And Technology Alberta, in addition to being a volunteer-led organization that promotes the growth and visibility of Alberta's tech companies, we actually have a couple of programs that students may be very interested in, work integrated learning programs. So check our website because you get to work for very cool companies like NanoPrecise. I've also talked at a couple of classes, including Russ's class last week and product management classes the week before. And some of the people in the classes actually have ended up getting jobs with NanoPrecise and other tech companies across Alberta. So introductions aside, I'd now like to introduce our keynote speaker today, who's Sunil with NanoPrecise. Sunil has been, you may have read his bios already. He's an engineer. He has his MBA from U of A, and his business is located in Edmonton at the Edmonton Research Park. And they are doing fascinating things that have attracted global attention. And with that, I'll let Sunil take it over. Everyone, help me welcome Sunil.
Thank you. Thanks, Gail. And it's always nostalgic to come back to the University of Alberta. It's my alma mater and first experience. Yeah, I hope you guys can hear me. All good? Okay. So yeah, so I think it's always nice to come here. So you know, definitely we are looking for to hire people for certain positions, not hundreds of positions, but yes, there are 2-3 positions that we are definitely looking to hire right away. So we can talk about that. And before that, you know, more importantly, what are we doing special that you know you should consider us? So I will talk about that. What is our vision? So what is a NanoPrecise? And I mean, I think Gail already told about my background. I'm a mechanical engineer, and I spent my time in oil and gas industry with Suncor, you know, Worley Parsons, and also in Korea and India. I did my bachelor's in engineering from India. So why I founded NanoPrecise? Because when I was you know, working in oil and gas, I could see that a lot of times, you know, they have sudden unplanned downtime due to rotating equipments like pumps, compressors, motors, and they will get really stressed out about it. And I was always interested in material science, and I thought that every material and its degradation can be tracked and can be told, you know, monitored, and customer can be notified in advance if there is a right technology. The issue was the right technology, and if we can do that, it's a huge, you know, savings, both in terms of production and also in terms of energy efficiency, because the machines degrade in efficiency over time. So at NanoPrecise, we're trying to give those accurate early warnings on these rotating equipments to the customer, and also tell them that if they do not act on those warnings, how much they're losing per week in terms of energy efficiency, and also potential unplanned downtime and production loss in the coming 1 month or 2. So why, you know, what are our values, and you know, why customers have you know, drawn to us as compared to tons of other technologies out there, companies out there? We have grown really fast in the last 5 years, 250% year over year. And the reason for that is our values, that our responsiveness. So the kind of culture that we have created at NanoPrecise is that we are not doing this for money, not just for money, right? Financial discipline is important, but we are doing this because we feel that this planet is going through a really tough time. And if we do not act, and if we do not bring speed along with quality, yes, quality is important, but you can't have that, you know, a quality product in 100 years. Earth does not have that time. We need to basically fail fast and learn fast approach. So that means that responsiveness is very important. And then open to challenges, understand the customer problems, because not every industry has the same problem. And there is not just, I mean, what we think is a problem do not have to be this problem for the customer, because they have financial incentives and all of that. So everything has to be balanced out pretty nicely. Ability to integrate with them, that, okay, we have a solution product, fine, great, but they have something working right now. How do we make sure that we don't ask them, you cancel everything, change yourself completely, and buy what we have? That does not work. It has to be like a very slow, gradual change for them, because every human has an inertia. So that needs to be understood. So that means proper integration, easy, seamless integration has to be done with them. And of course, open for innovation by understanding. So that's what really attracted clients for us, because a lot of companies, they basically just say, okay, this is what we have, you want to buy it? Otherwise, we are going to some other customer, right? So we are not like that, because we feel that we are here for a vision, and that vision means we need to be flexible, but at the same time standardized, because too much customization is also not good for scalability. We also have to run the business. We are not a research house. So, and our capabilities are, that we have an IoT-based sensor, and I can talk about that in a bit, and AI-powered software. So there are multiple features of that, like what kind of, connectivity protocols we use, and what kind of AI models we use, because this topic is about AI. How we are doing AI a little bit differently than a lot of AI-based companies like DeepMind and all of them do. So we can talk about that, but those are some of the things that we do differently than others, and those also are our capabilities. And of course, certifications for the company, because when you talk about, okay, we are cybersecurity compliant, the words does not matter. What matters is what are your credentials, and credentials are like, we are a SOC 2 type 2 company. Our sensor has a zone 0 rating, so that it is basically safe for so those credentials speak more than the words. So this slide is very important, and what this tells is we are monitoring around 13,000 sensors right now on 5,000 machineries across different industries. By the end of this year, it will be 2 times of that, at least. So what we saw in that, at any given point of time, 8% of machines have a problem, irrespective of the industry, right? So we know this, right? And we can tell this to the customer. So that's all this slide is about. And why this also helps us is to tell the customer that if you want to do a project, right, you should not be penny wise, pound foolish, and saying, like, customers should not be penny wise, pound foolish in their thinking that I will just select 2 machines and I will do a pilot on this. That you need to at least select 10 machines. Why? Each one machine will mean 4 sensors. 10 machines will mean 40 sensors. 40 multiplied by 10 multiplied by 0.08 probability is 0.8, means you are at least probable enough to see some kind of a failure in the next 6 months. So that will, and if we are able to catch that in advance and tell the customer, they can see the ROI. So at least in 6 months, we can provide some ROI, and that can lead to scale up. So that's why this slide is very important. So let's talk about the success stories a little bit, right? Like how, and then I will delve into AI more, and how is our AI different than the AI being done in the research centers and all that. So this is one of the gearbox, and if you are a mechanical engineer, you will understand this. So gearboxes are basically needed to, in manufacturing industries, and they are run by motors. So this is at a customer site called Nutrien, which is a very big company in Canada. So we saved $700,000. This is the number provided by them. So actually, it can be more than that, because customers are always conservative about what they tell you. So, and the amount of sensors they had was 4, and they were monitoring 25 machines. So basically 100 sensors. So if you look at our cost to them per annum, it is not even $33,000. But the impact just in 6 months, just in one machine, just in downtime is 700,000. So it's like an insurance policy. It's not like you should have it or not. You must have it. But the AI has to work. If it did not detect properly, if there's a false positive and false negative, it falls apart right away. The trust kills right away. That's the problem with the AI, that it's either 0 or 1. 0.8 probability, 0.7 probability it will fail, doesn't work. You like AI works like that, but when it comes to notify the customer is like, tell me there is a fault or not. If it is not, don't disturb me. If it is a fault, then tell me yes. And if I don't find it, take your sensors, get lost. So that's how very tough the practical world is. So okay, so to do that kind of analysis, accurate analysis, first is the quality of the data. What quality of data you have, because otherwise it's a garbage in, garbage out. So the first thing we had to do was understand how they have been doing this for the last 30-40 years. So they use something called a handheld analyzer. So it's like a technician. He takes the vibration handheld analyzer, goes to the field, and just like a doctor used to do in the olden days with a stethoscope, he puts a probe on the machine, and he sees the values on his screen on the analyzer that is tied to his neck. And if everything is okay, he will go to the next one. And also he comes back to the lab and downloads all the data and does it. But that is a very manual process, right? But an important thing there is that analyzer at least gives a very quality data, right? So when we had our product, we cannot tell the customer that you just focus on our AI and our analytics. Don't worry about matching data quality from our sensor to your analyzer, because even that has to match. Because if there's a huge difference, and if we do not do right by chance, if we do not inform them about some insight, they will check the data with their analyzer, and there's a huge difference, they will throw it right away. So that's why the first step, even though this is like let's say $250, and that analyzer is $25,000, 100 times more, the data quality still has to match, right? So that's a big expectation. So we did that, and we compared it with Emerson's handheld analyzer, which is $25,000, while ours is much cheaper than that, but the data quality matched. And now we have done this analysis at hundreds of, at least 25 customers all over the world, and it matches. So that was the first point. And why that is important? Because that is the real disruption. When you bring a sensor that can provide the same data quality as something that is existing in the market that is 100 times more, that itself is a disruption, first disruption, right? Then we will come to the AI and all that, so because after that, proving everything else becomes pretty easy. So so this is another one where we actually found a fault on machinery in a cement plant, which saved them 8 hours of downtime. You can see a peak there. So why, and I will talk about this a little bit more. There is a reason why, we do something called physics plus AI, not like I would say, domain expertise powered AI, rather than just a, black box neural network model based or AI, because we found that, the probability of success is way higher with much less amount of data. Because you have to understand, if you are generating 99% accurate result with 2 terabytes of data, right? That has to be labeled properly, and that labeling of data takes so many hours, compared to getting to 95% accurate results with 1 gigabyte of data. The difference is huge, because the cost of producing 2 terabytes is much more. So you are not viable and comparable. And the customer can say, I'm okay with 95% as long as it is above 95% confidence interval, right? So that's why we had to come up with physics plus AI to provide that quick value for the customer. This is just an example of simple, like how the change was seen, and customer was able to believe on that and take action at the site. So this is the overall data structure. So this one sensor can detect 6 parameters. It detects vibration, acoustic, surface temperature, magnetic flux, RPM, and humidity, all with one sensor. Especially because vibration, acoustics, temperature, and magnetic field, these 4 are very important parameters for anything to determine the health of anything in this universe. So that we send that data to the cloud. So that is where automated analytics happen. So basically, when I say automated analytics, there are 3 basic objectives. First is anomaly detection, that okay, if there is something weird in the data, right? After that, because not every weirdness is bad. Weirdness can be good, weirdness can be bad, but it doesn't mean something bad only. So the next step is fault diagnosis. What is after you detect the anomaly? What is if that anomaly alludes to some problem, right? So we do the fault diagnosis, and then after fault diagnosis, because just imagine this: if you have a simple shaft and you install a bearing, on the first day, 30% of the bearing life is gone. So should I tell the customer on the first day that there is a problem? He will say, I know that. Don't tell me. Tell me when there is a material change in that. So when you say about a fault, about a specific thing, you need to tell it how much time to failure. And if the time to failure is more than 2 months, don't even bother customer, right? So keep tracking that. And when it is less than let's say 2 months, which is the tolerance window for the customer to be able to order a new component or something, that is when you have to notify. So that's why you have to do remaining time to failure. That is the 3rd step. And then the 4th and 5th step is, okay, we told about anomaly, fault, and how much time to failure. What is the corrective action, right? So what can customer do to correct that? It's basically like how our doctors do the predictive analytics for the human body, right? It's the same approach, actually. So the 5th step is basically finding out what is the root cause. So we use some kind of AI there using like the data that we have generated, and of course rule-based systems too. And then the last one is, okay, this is the root cause. What are the corrective actions for each root cause? So that's the overall system. And the last mile integration that we do is with a CMMS, computerized maintenance management system. So what is that is, okay, we have this automated analytics has been created, but how it lead to an action on the field, because insight is nothing if it is not acted upon. So this last mile integration with the CMMS system automatically creates a work order on the customer side that okay, this bearing is going bad, potential cause is lubrication. Make sure that you have a work order gets created for potential lubrication in the next 1 week or so, right? So that's how is our last mile integration. So let me explain you what's the difference between the typical, like the AI and ML that we do, and typical AI ML that is carried out, and why we chose to go for physics plus database model rather than just database model. And so let me just explain you about this. Specifically, yeah. 1 second. So if you see this chart, frequency spectrum. So if you notice, there are, like, let's say there are 8,000 lines of resolution on this axis. How many times, in how many ways you can select 2 peaks? You can select it in 8,000 multiplied by 7,999 divided by 2. That's the number of times, number of ways you can select 2 peaks. Why 2 peaks? Why this and this peak? Because whenever there is a fault, it is a given that it will always occur at harmonics. 2 harmonics has to, peak while the noise floor would be low. So how many times, how many ways you can expect a fault? So that will be 4,000, because you can select a peak in 4,000. The other peak has to be twice of that. So if you take a ratio at any given point of time, what is the probability that there is a fault at any given point of time when you take a spectrum? It will be 4,000 divided by 8,000 multiplied by 7,999. So the probability of there being a fault at any given point of time is 0.006%. What that means, if we can catch this incident with our sensor, the accuracy of that is 99.94%, right? So that's the reason why we understood that this kind of automated spectrum-based analysis. And then on top of that, once you find out that there is a fault, okay, if this and this peak is matching, and this peak reflects to the frequency, let's say, 2 times of RPM speed, which is, let's say, 1200 revolutions per minute. 1200 divided by 60 is 20 hertz. So there are 2 peaks, let's say one at 20 hertz and at 40 hertz. So we know that there's an unbalanced problem in the machine. So once we know that, then based on the amplitude, you can predict in how much time, and we have a threshold value of amplitude. Let's say it will be velocity of 20 millimeters per second. Right now it is at 11 millimeters per second. So over time, how it is, progressing towards its failure, we can predict the remaining time to failure. So these 2 things together will help the customer. But for that, you need to use both physics, because you need to use the characteristic frequencies of every fault mode, and the rule-based or unsupervised learning of, let's say, Weibull distribution, Gumbel distribution, whichever fits the pattern the closest of how it is reaching to its failure. So together is what we feel, what we have seen, leads us to higher accuracy for very less amount of time. Because what we are assuming here is simply that customer does not have any data. So that's a very powerful thing, because if we ask customer that we will install this on your machine, and for the next 2 years, we will take data, and if you have any faults, tell us, we will mark it, and after 1 year, we will start our analytics, he will be mad about it, because he'll be, I want ROI right now, like within the next 2 weeks or 1 month or 2 months, right? That's the real world. That's how the real world is working. So how, and if you look at the typical database approach, right? What that is they, a lot of companies are doing this, that they take sensor data, they do some signal processing, right? Some feature extraction, data tagging by experts, and then model training and split testing. They use different kinds of k-means clustering or neural network, of course, and like a training set, validation set, all of those things, which is pretty normal. I think you guys know that pretty well now. So the issue with that we see is that, it needs this much amount of data to be able to reach the accuracy that we are coming. While ours, you're talking about basically, we just need, 2 weeks of data. That's it. I mean, we can actually do it right up front after one waveform is there, right? But the reason why we need 2 weeks of data is to trend the amplitudes of those fault modes to see that, is it growing or is it just a fault that the customer can, because a lot of faults, customer can live with that for next 5 years or so, right? So not every fault is bad. So the rate of change of fault is what customers are really looking to. So that's why what I feel, and the message I want to say or give to everyone, domain expertise is really important if you want to do anything with AI. If you are working on something where domain expertise, you don't have domain expertise in that, you should not do, according to me, you should not do AI in that domain. If your domain is in machinery, you should do AI in machinery related systems. If your domain is in environmental monitoring, you should do, like if you want to do, AI and environmental monitoring, you need to have some domain expertise in that, because without domain expertise, it's just, black box, and it can fail you anytime. And in the real world, it takes you maybe right 99 times. If you are wrong 10 times, that's it. Your credibility is totally gone, because you're no different than an astrologer who is telling you that, oh, your luck is going to be good in the next 10 minutes, right? So that's why the scope for error is, margin for error is really less. So for that, domain expertise plus AI is the way to go, not just AI.
And that's how you build up your team.
Exactly. 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 Yeah. Sorry? Yeah, I think that's the part and parcel of the whole process, because unlearning and relearning is very important. But what I think is very fundamental is always stay true to those physics and chemistry and mathematics fundamentals. And because if you're not there, if you're trying to if you forget that, there's no substitution for that with the chat GPT or AI and all that. Those fundamentals are the core. That is what the whole universe is built on. That is the core, and then comes everything else, not other way around. Yeah. So all this hype, whatever you have, just understand that that is only built on, that can only be true if it is built on fundamentals. Wherever it is not, going against the fundamentals, be rest assured it will fail. It's just a matter of time and how much time it will fail. Yeah. Yeah. Sorry. Yeah. Yeah.
So thinking that tried this system in different applications and different industries, right? Is there any way to find a generic definition of faults, or do you have to, for example, redefine what the fault is and what features need to be collected for every single domain or application that you're looking into?
Yes, that's a great question. So we actually have a small lab in our own office, a motor, gearbox, and we can change loads and change speeds and all that. But the point is, we can only, and we can expand that lab to include pump, compressor, turbine, all kinds of equipment. But in the real world, there are many more permutations, combinations. Like you have pharmaceutical is totally different, oil and gas is totally different. Within oil and gas, you have multiple sectors, like coking area is totally different than the utilities area. And within steel plant, your ground mill area is totally different than the cold mill area. So I mean, the permutation combinations increase so much in the outside world that it becomes almost impossible or unviable to recreate that in the lab. So that's why, and that is another reason why we did not go to, we could have charted on this path, that because for the kind of analytics we are doing, we have to get few inputs from the customer, which are bearing number, the gear ratio, and number of rotors, number of status. So some information customer has to provide. We could always build it like, okay, we will make it easy for the customer. We will not need any information from the customer. We will just let the data come, and if it matches a certain outcome based on our model that we have trained, it will spit out a probability, right? The problem with that approach is that we need like a whole load of data. That's what I'm explaining here, that even if you have 80,000 machine configuration, let's say 8 faults, each machine can have, even let's say 8 faults. 8 faults are really basic: 4 bearing faults, 3 shaft faults, and 2 gear faults. Even that itself is like 8 faults. And 80,000 machines are in different, like even if you take top 10 OEMs, you're talking about so many different kinds of machines. And then you have you take 1,000 samples, probability of fault being 8%. You need 8 billion hours of data to be able to get to that 99.99% accuracy And that is just not possible. And that's why we had to come up with a way to be able to, reduce the requirement of that amount of data, but still meet that 99% accuracy. That is where that physics plus AI model really helped, rather than a black box neural network model without the physics spectrum analysis at all. Yeah. Hope that answers your question.
Yeah, so there are, in fact, maybe approaches that we can combine this with active learning, and that data like driven approach can actually help you solicit feedback from the experts in the domain. So this is just reducing the cost of collecting labels from people. And then the other thing is that surprisingly, the faults in mechanical and electrical systems, they are very similar. So maybe this is not something that is obvious at the first glance, but if you look at this, we have something called the stochastic fault, right? Yeah. Stochastic fault is the same fault, right? Everywhere. We have something, let's say, different, right? In mechanical systems and electrical systems, we often see the same type of fault. So, and data-driven approaches can at least help us identify those cases that might be a fault, and then you can show them to an expert and say, is this really a fault? And that could help you collect more data.
Yes, yeah, you're absolutely right. Like what we have personally seen is that black box model helps you where you do not know about any physics, or like it is not governed by physics. It is governed by some very complicated mechanism which we don't know. That's why we are letting neural network learn from that, right? And that's why we still call it as a black box. But here we know that for sure, as you said, that every machinery is, its degradation is a continuously increasing function. If you don't do any maintenance, it will never be like, it can be going up and down a little bit because of the stress cycles, but overall, you know that it is a continuously increasing function. But if you talk about the stock price, or basically any of those, like whether users will buy this particular product and all that, that is not a continuously increasing function. That is totally, governed by a very complicated mechanism. So that's where you need like AI-based model, where like by training, inputs to outputs, and wherever there's a continuously increasing function, you can just take help of the database, like rule-based systems, and achieve to much higher accuracy with much lesser amount of data.
I'll just do a quick time check.
Yeah.
We have about 20 more minutes, and so the science behind the product, as well as a little bit more on your business and future opportunities, would be great to cover too.
Sure.
Thanks.
So this is what our overall dashboard looks like, and so basically we have most of our customers have multiple plants. Each plant will have multiple equipments. Each equipment will have multiple sensors. So what we are really doing is that we are telling them like a overall view on a specific plant, what all machines are bad and which are healthy, so that they don't need to focus on them. And then giving them a comparison between their different sites. For example, if it is a Suncor, how is their one site doing compared to others? And then also now we have added, I will just talk about in future slides, energy efficiency, and the how much their energy loss has increased in the last 1 week as compared to the first 1 week when the sensors were installed. Because they need to understand that, the technicians needs to understand it's not just about the unplanned downtime, but also inefficiency and how much it is costing in terms of energy becomes important. And now we have also added carbon emissions in tons in last 1 week based on extra energy consumption, so that they can take action based on that also. And this is what our component-based dashboard looks like, that what is the remaining time to failure in hours or in percentage. We give it in hour percentage when it is more than 2 months, because customers don't need to worry about something that is more than 2 months. So we don't need to tell them like, okay, 6,000 hours remaining to failure, because it's too advanced a notice. So you can just say that you can just call it as a wear percentage, how much the material has worn out and how much is remaining to be worn out. But when that remaining time to failure is less than 2 months, that percentage automatically gets converted into number of hours, so that they know that now I need to act before it's too late. And also recommendation, and in terms of the root cause, and that automatically shows up there, and fault mode, misalignment, and like the health status, utilization factor. So that's what is the potential root causes and the suggested actions look like. So if you click on the suggested actions, that will show that too. So it will show what is the potential suggested action for each potential root causes. So we are trying to make it more pointed rather than giving 5-7 types of potential root causes. Right now we have to give like that because we have not yet generated enough data that we can for sure tell these are the two. We have to give them options, because if we don't give them options and they find out that it was bent rotating shaft rather than dirt accumulation, then it's not a good thing to. It will be like lying, right? So we don't want to lie. We want to tell them all the potential root causes and suggested actions for those potential root causes, so they can try. Yeah, sorry.
These statistics you get like 50 hours left, 49%. That's been validated at the factory or by the community. And when you find the root, how do you show actually that you're giving the right answers?
Yeah, great question. So basically, what that 50 hours means is the remaining time to failure to reach to threshold point, right? It's not remaining time to catastrophic failure, because the catastrophic failure can happen anytime after. No one can tell that. It's very difficult to pinpoint when it will break exactly. But what we are telling is that in 50 hours, based on this trend, based on, let's say, a trend like this, I think I showed somewhere here in the, based on a trend like this, this is a little bit more obvious because this is quickly, but let's say it's something like this, and it is remaining time to fault stage 4 threshold value is 50 hours. Then basically customers know that, that I need to take some action, because that 50 hours is can be changed based on the machine. The next spectrum that we get in the 6 hours, this 50 hours will be probably, it will be probably something like 100 hours, or it can be something like 25 hours. I mean, it will not vary beyond plus minus 50% usually, because we have already stabilized the baseline and all those normalizing techniques and all that. But what customers really want to see from there is that if they see less than 500 or 750 hours, they know that they need to make this, and if they have less than 100 hours, they need to take an action right away. So we categorize our notifications in 4 ways. One is, you have a question?
Well, you're saying if the model's correct,
yes,
it'll be 50 hours.
Yes.
Is the model correct?
That's basically so that's because they can't measure that 50 hours because
they could. They could just watch the machine and 50 hours later, oops, he was right.
And
if it broke at 49 hours, they say you're right also.
So what they measure is that is whether they validate it by taking their own handheld analyzer and going to the equipment and seeing the peaks on their own system. And if that peaks and the amplitude is matching, then they are sure that yes, the fault is there. Now, whether it will stay for 50 hours or 100 hours, that is something, if it is, let's say 50 hours, then they will probably do something in the next, let's say 25 hours or something like that. But they are okay to do that, even if it is 100 hours, right? But not 50 hours. They will still take an action in 25 hours because they have to resolve it anyways. It's just a good practice. but they will not, really check that, because if they start checking it with a clock, it will not be exactly 50 hours, because it will be, it can change. It can change based on because material is smoothing out. So this 50 hours, what we are saying is true at this point of time. After 6 hours, this can be 75 hours. After 6 hours, this can be 33 hours. You understand what I'm saying? Yeah.
It's like a caution flag.
Yes.
What would it mean? What would it mean to say that your model was wrong? How would you falsify this model? You said 50 hours, and clearly if it takes 49 hours, you say that's fine.
Mhm.
If it takes 200 hours, you say, oh, maybe I was wrong to say 50 hours there.
Yes.
And so what, if the numbers can change that dynamically,
Yes.
why would a customer want to see a number that you say, well, it's different later on?
Yes. So, I mean, what does it say? It says that remaining useful life, right? So beyond useful life, you can still use it. You can still make it basically take more energy and, keep it burning. So it will basically still be keep running. It can take 200 hours, but how optimally is it running? So this 50 hours is basically the optimal time. Yeah.
I think I understand the point being, okay, it throws a number that may not be exact. At what point would you throw out the model? But I think you answered it in a different way. You actually said this flags, it's like caution. They go out and have their own handheld sensors.
Yeah.
And that validates that, yes, something is wrong.
Exactly.
And then they look at it more. So it's more to take the action to go out and send out expert action. if you will.
Yeah. Sorry, go ahead.
I was just gonna say there's also usually they will tear down any piece of equipment after. So if they're tearing it down and there's clean bearings, then they're gonna
They would do
talk
that
to you.
anytime.
Absolutely, yeah. And that is actually, if that's a great point, and that is what we have been able to showcase in some of the, I don't have those case studies here, but they have been able to, like we told bearing in a race of failure, right? And it is approaching fast. So some of the customers have gone to the extent of opening the bearing, and they found out the scratches on the bearing in a race. With Edmonton International Airport, because we installed our sensors on, the gearboxes, like you have this conveyors where your luggage goes. So those gearboxes are suspended in the air. If those gearboxes stop, you will not be able to, give your luggage, and it will cause, a lot of delays at the airport. So we have been able to catch a bearing ball failure there. So they opened it actually, and they found out pittings on the bearing balls. So what we have seen is that the reason why we put that 750 hours is because once it reaches to that number, based on our own data, we have seen that you are seeing some kind of structural damage on that. Once you have structural damage, after that, the time does not matter, because after that, it is exponential.
It will fail.
Yes, and you don't want to take that risk. And yeah. Yes. So
That's
will
right.
not be a
I'll
failure.
repeat
That will
the
be
observation.
yeah.
If you open the piece of equipment and there was no problem,
That will be a
then
false
it's
positive.
a false positive.
Exactly.
And then that is a big
Yes.
deal, because that's a cost disruption in production.
Yes. Yes.
You're recording false
Yes.
positives.
Yes.
And
So,
just a time check. I think you have 10 minutes.
yeah, we are recording false positive and false negatives. Yeah. So our KPI actually that is our KPI to the customer. So we have 10 KPIs. So false positives are less than 1%. False negative is less than 1%. Usually right now we have seen less than 0.1%, but we want to be safe. So we promise less than 1%, promise less, deliver more. That's the philosophy here. And then our false negative is less than 1%, and false positive is less than 5%. So because false positive is still, we're learning a lot, and we tell the customers that, for the first 2 weeks, you can expect some false positive, and we need your feedback. We need to learn from you to make sure that we reduce those false positives, right? But still, I think overall the number of notifications and all that, they are small enough now that like they are like one of the ratios that I got is that we send one notification per machine per month at max. If we look at all of that, while some of our competitors, they send like 4 times of that number. So that's really important, right? What you say, like for that false positive and false negative, because otherwise what will happen is the trust will be gone completely on these kind of technologies and AIs and all that. That is what actually one of the big problem why IBM Watson is a failure, right? So, and I hope
too
everybody.
many false positives. Yeah. And perhaps not the domain knowledge built around it.
In a very important space like health, right? When you talk about health, I mean, we are talking about health of machineries. They're talking about health of human beings. You cannot zero false positive. I don't want somebody else telling my daughter. It happened with me. Like I took my 3-year-old son to University of Alberta and emergency. So he's having a lot of fever and all that, and they took an X-ray. They said totally fine. 2 days later, they're calling my wife and saying possibly there is some pneumonia. Can't you tell this 2 days before? And now giving me antibiotics? This guy, poor chap, has been suffering for 2 days. So in the healthcare, and I actually complained about it to the MP that if this is expected from a University of Alberta's emergency, what we can expect from normal private healthcare here? I mean, if at all,
Which is why data methods are really helpful, because the doctors need the tools, better tools than just visuals.
Yes.
So just so you know, about 5 more minutes.
Sure. Yeah, I think we are pretty much covered the most important parts of it. So I will talk about just about the energy monitor. So without talking much about our own marketing material. So this is something that I'm really passionate about. This new product, this new feature that we have added in our product, because as I mentioned, we are all really focusing on energy efficiency and how to reduce CO2 emissions. Just a simple figure: 50% of world's electricity consumption is with electric motors. So if we can increase the efficiency of and it is going to go up, as you know, with EVs and all that, electric motor is going to go up. So if we can focus on our simple analysis based on this slide, tells that like simple shaft misalignment fault can increase power consumption by 10%, if not more, right? It will lead to failure in 2-3 months. Fine, if you leave it like that. But for these 2-3 months, you are unnecessarily emitting more energy. A simple study by a very major company called Proof Technique, which is acquired by Fluke now, it tells that 91% of motors in a plant are misaligned at any given point of time, right? So that's a massive thing. So our analysis says that just by doing proper maintenance on the machinery at the right time on an appropriate equipment can help with global emissions by at least 3 to 5%, if not more, right? So that is massive without doing any solar panel or wind energy or Tesla and all that, just by doing right maintenance at the right time. And it actually applies to us. Make sure that you do oil change in your equipment at on time, because you are unnecessarily, it doesn't like you don't notice the increase in your decrease in your mileage and all that on time, but that is because till now we have been treating this environment as a garbage dump. That assumption has to go away if we really care about this planet. And this all starts with these small things. So yeah, so as you can see with magnetic flux, we are able to do power consumption, track power consumption increase. So because you can see the R square between power consumption and the magnetic flux. So we just mount it on the motor drive-in side, on the non-drive-in side, and it creates a magnetic field around it. So based on the changes in that, we are able to track the power consumption. The best part about our solution, and how it is different for others is there are hundreds of energy monitoring solutions in the world. Okay, the problem there is that what they will do is they will if let's say this is a plug, they will put a energy a clamp type current sensor right there, and they will monitor what is the change in the power consumption. That is not good enough, because the customer is not interested in what is my change in power consumption. He's interested in what is the change in power consumption due to a fault mode, right? Because he's not just, if he's consuming more power to increase his production, he has to do that because that adds to his bottom line. He cannot just say, I will stop, I'll stop my machine or not produce more, just want to save the environment. No, that is not how it works. But where it is costing, unnecessarily costing him more energy because he has a problem in the machinery, that is for sure he wants to avoid, because it's a pure hit to his bottom line and also to the environment, right? So that's what we are able to tell with the magnetic flux, is that we are telling them for every fault mode, what is the increase in energy consumption, and converting that into dollars and the carbon emissions in tons. So I think that's pretty much it. In a nutshell, why we are different is basically we have used a very conservative approach to AI, which is physics plus AI, which takes less data for the same amount of, or almost same amount of accuracy, which is more than 95% confidence interval. We we cover most ranges of machines, like from 40 to 5,000 RPM, really wide range. We do integrations with the customer so that we don't just assume that customer will change their existing system and use our system without worrying about what they have right now, right? So we basically understand that and handhold with them through these integrations to do it in a gradual way. And then with six in one sensing modalities, we are able to catch electrical faults, mechanical faults, structural faults. Like all the faults in a machinery, you can basically categorize into electrical, mechanical, structural, or at most instrumental, instrumentation related faults, panel related faults. But those are not we are worried about. It's mostly these three types of faults that they're worried about. And last but not least, I think the certifications, because when you talk about hardware, software, cybersecurity, everywhere, just words are not enough. You need to have credentials, and these certifications add those credentials. So I think that's pretty much it. Yeah.
Well done. Thank you, everyone.
Thank you.
Please help me thank our speaker. Also, can you tell us a bit of some corporate information? You received a large amount of investment recently. Can you talk a little bit about that? And if you're hiring for any positions? Sure,
yeah. So we just, as you said, we just raised $13 million funding round, Series B funding round with 4 major investors. One is Government of Canada, Export Development Canada, and then Honeywell, which is a major company, and NSK Bearings, Japanese company that deals with bearings and all that. It's a very good fit for our kind of solution. And then an investment company called investment bank called ECM&A. So what we are really looking for right now is someone with some mechanical or electrical engineering background and who has really good Python coding skills, right? And is interested in, and believes that global warming is real. So, and can work with us to make machines more intelligent and smarter. Yeah. Excellent. All right. Well, thank you again, Sunil. Thank you, everyone. Feel free to stay. Well, yes, we can thank him once again. Thank you. Yes.